In this video, we will look at how a flexible pavement works. That is, how it supports the road loadings and distributes those loads so that the road can be supported by the subgrade, and how it can do this for years without breaking apart. The key is getting the particles to lock together to form one structure. If you are unfamiliar with the concepts of force and stress, then I suggest you review the force and stress video on Moodle, as these concepts are important in understanding how a road works. The roads we're looking at are flexible pavement roads, which is what almost all New Zealand roads are. The road loadings are supported and distributed by the base course, then the subbase, and then the subgrade. The base course and subbase are unbound granular pavement layers. This means the aggregates are not bound together and rely on the interlock between the particles to hold the layer together. This is different from other engineering materials. For example, the aggregate particles in concrete are bound together with cement. You cannot easily separate the aggregate once the concrete is set. However, you can break an unbound granular layer back into its component particles if the layer becomes unraveled. So we need to maintain the interlock in the unbound granular layer to allow it to resist the loadings it experiences without unraveling. This interlock is achieved by the compaction of the layer. The compaction pushes, kneads, and vibrates the sand and gravel particles into a dense layer, with finer particles wedging in between coarse particles and holding them in place. Basically, the coarse gravel particles form the primary load-bearing skeleton, while the finer particles hold the coarse particles in place and also distribute the load. There are several loads on a road that a granular layer needs to resist. Let's look at the vertical force applied by a vehicle passing over a section of road. Basically, the weight of the vehicle exerts a force on the base course over the area of the base course that is in contact with the tyre. This is called the tyre footprint. A force applied over an area is a stress. In this case, it is a normal stress as the force is applied at right angles to the surface. When the stress is applied, in this case by the vehicle tyre, the base course and subbase resist and distribute the stress via contact points between the coarse particles, as shown by the green arrows. Note that the stress from the tyre is distributed over a wider area throughout the layer thickness. This means the stresses at the bottom of the layer are less than on the surface. The stresses will get distributed and reduced further if the layer is thicker. This distribution of the surface stresses means that the base course and subbase reduce the surface stresses to below the bearing capacity of the subgrade. The bearing capacity of the subgrade is the stress that the subgrade soil can resist without failing or settling excessively. Our aim is to make the base course and subbase layers thick enough to distribute the stress to well below the bearing capacity of the subgrade, as any movement of the subgrade will affect the road surface. A second loading on a road is the horizontal forces created when a vehicle turns, brakes, accelerates, or climbs on a steep slope. In all of these cases, the movement of the tyre is applying a horizontal force to the layer. The force is applied over the area of the base course that is in contact with the tyre, that is the tyre footprint. A force applied over an area is a stress. In this case, it is a shear stress, as the stress is applied parallel to the surface. You can see the effects of acceleration when someone does a wheelie on a gravel surface. The stones get spat out from under the tyre. Alternatively, the stones ride up in front of the tyre when someone brakes heavily on a gravel surface. You can see the effects of turning when you see a rally car cornering on an unsealed road with surface stones flying off the sides of the tyres. This diagram shows a shear stress being applied by vehicle braking as the red arrow. The horizontal force is resisted and distributed through the base course layer via the connections between the coarse particles, as shown by the yellow arrows, with the fine particles stopping the coarse particles from moving. This is the same mechanism used to resist vertical forces we looked at in the previous slide, although in this case the stress, or the force, is distributed along the road layer rather than through it. Note that most of the horizontal force is resisted within the base course, and the subbase often does not have to provide much resistance to horizontal forces, horizontal stresses. That is one reason why we use a higher quality aggregate for the base course.